sir. Okay, from here we'll start digital inputs. Okay, digital input. I think just with the LED blinking, it consider as a digital output. And now we'll explore the digital input through the button, right? And for that, our STM32 nuclear board has inbuilt button, right? You can see there should be one blue color of push button, right? Blue color push button, so it is inbuilt button, is directly connected on a specific GPIO pin. Okay, so what we will do, we will toggle the LED, we'll push the button, we'll read the state of button, and we'll control LED. So this would be our demo, as the button will work as a digital input, and our controlling the LED will work as a digital output. What will hardware we are going to use? A single P1 button. It is directly, internally it is connected on the port C 30 number pin. Okay, and our LED is directly connected on a port A 5 number. Okay, and for debugging console we'll use SWV or using the UART2. Okay, so let's first understand the button circuit, how it is working on a STM32 nuclear board. Okay, so this button and LED is connected over STM nuclear board, right? On the board, not the IC, right? Connected with the IC, but through the board. So it has a pull-up register of 4.7K over the P port number C 13 number pin, right? So this push button is directly pull up over 3.3. Then the button state not pressed, that means 3.3, and if pressed the button, it should be 0, right? An important concept, this is called active low input. Like there is active low and active high. Matlab, when button press, active low, I mean button release, it is called logic high. Where is low and high? On the pin number. Okay, that means our pin number, that PC13, goes low when we press the button, and it goes high when we release the button. It is called active low input. And in case of active high, this logic gets inverted. That means in that case, when we press in logic high case, when we press the button, it will go high, and when we release the button, it will go low. Just opposite of active low input. Okay, what is GPIO input? So it is general purpose input output, right? And it should be 3.3 high voltage to GPIO pin set, and 0 volt we call it GPIO reset, and we call the higher state GPIO set. These are the GPIO input mode of GPIO pin. It could be in 3 different kinds of mode. GPIO non-pull, that means no internal resistor, external pull-ups we can add, right? And GPIO pull-up, right, that means internal resistor to the 3.3 button circuit. And GPIO pull down, internal resistor to the ground. These are the 3 different mode on the basis of the pull up pull down, right? So in the especially in this board, GPIO no pull, that means this is no external resistor, right? No internal resistor. In internal, that means in IC level, at the side of GPIO board level, it is added only external prop resistor already. Yep. The problem is like button bounce. Last time we have this this thing on a ESP32, the debouncing case, right? That means the noise between the high and low, right? You can see it clearly here. The button state, right here, between the low and high. So controller will not understand is it completely low or completely high. So that's why we solved it through the what we call that quantization or sampling technique. Okay, so yeah, debouncing concept is like detecting the change, start timer, waiting for 2 milliseconds, very less time, right? Read button again, if the state same, valid press, right? So as a debouncing, we just add some delay between the pressing and between the high and low voltage, between the reading of that state. So in why halt get ticks instead of halt delay? So halt delay block the CPU, right? So recent last time we have seen the millisecond instead of the delay, right? Or we task delay instead of the delay. So in the same case here, halt delay, it's like the normal delay instruction, or halt get ticks, it is like getting the millisecond or using the we task delay in STM32, right? And what this function will return, it will just return millisecond, right? Since a boot, whenever this controller will get boot, the millisecond get start, that we call it ticks. So hal get ticks will give the count values for the count value of millisecond from the booting stage. Example 1000 millisecond, 1020 millisecond. So how we'll check that? Current time minus previous time, it should be 20 millisecond, right? Then we'll assume it is a accurate state. Okay, so it's time to practical. Start your QMX, create new project. Okay, and select your board, configure PC13 GPIO input, pull non-pull label B1. Okay, and step 3, considering the GPIO configuration for the LED pin and configuration for the UART2, and then generate code. Simple. So what we'll do, ओके स्टार्ट प्रोजेक्ट, न्यू प्रोजेक्ट क्रिएट करो, उसमें सारी चीज़ स्टार्ट से करो, इनिशियली से, ये वाला. Hope you will do it. Let me know if you need any help. Your project, board selector, select your board. What was the name of our board? Nucleo dash F103 RB. Click here. And if you want data sheet of this, you can also download the different kinds of resources and data science for it. Initialize all peripheral with default. Click it yes. Okay, but watch here, attention here. What we are talking about, if you check here, it is saying the configure the button. First of all, PC13 as a GPIO input, right? Search here PC13, where it is PC13, you can see, but it's already by default, just because we have selected the yes, so it is already initialized the basic peripherals. B1, right, is a GPIO external 13, right? And what is saying that no pull up. Okay, it is already selected GPIO input button, so I think we don't need to change much on it. It's already added as a push button. Now next thing is configure the LED. What is that? PA5, it is already there. PA5, okay, GPIO output already here. So we have we are going to use two pins, PC13 and PA5. Okay, GPIO input done. Then what was the next step? You can check, because we are already basic peripherals enabled. So if you check the connectivity, UART2 should be enabled, should be green. UART2 already there, right? Our third task was configuration the UART2, and is already enabled, right? Asynchronous mode. Fine. Finish. Next is generate the code. Okay. And but before that, project manager, give the name. Project location should be like this, right? select here STM32 cube ID. You can unselect it, or fine. The location should be like this in your workspace. Give it a name. I think I already have the same project, so I'm not going to create again. Okay, and after that open project in your IDE. This is the code. I think it should be available on website. Yeah, code is available on website. You can directly copy and paste in your ID. How you will build it? Click over the project, build project. It should build without any error. Then debug STM32 application. No, ST link restarted. Okay, so I think I have to close few projects. Let me remove it because it was running in other project. So what was that project? Let me close it. Window, show view SW data console. Click here. What the fail to disable? Disable HTML configuration. What is the meaning of that? Buddy?
मुझे बिल्ड करना चाहती हूँ पूरा प्रोजेक्ट रन करने के लिए डिबग अभी तो लगाया नहीं है फिर भी
तो स्टीम लगा बिना स्टीम लगा के डिबग कभी नहीं होगा एलईडी जल रही है।
Yes, sir.
ओके, वीडियो बना के डालो ग्रुप में।
बट सर मेरे उसमें ये SWV में जो ऑन ऑफ का स्विच ऑन कर रही ऑफ कर रही तो वो शो नहीं करता है।
करते हैं, नोटिस कर रहे हैं। क्या हो गया भाई, ये कहाँ से आ गया? डन गाइस, कितनी का हो गया है? इतने सारे पर डन हो गया सबका? प्रवीण, सुमित, दिखा ही नहीं रहा भाई कोई भी। हेलो। हो गया ना आपका सुमित एंड प्रवीण?
Yeah, no, no problem. We are to give me 5 minutes.
Okay, Sumit, any issue?
Not till now. Just checking here. Give me a sec.
Okay, so for others, guys, for others who have done, there is one bug in my program. Whenever I'm trying to resume my program, I am getting error that my program is going into the hard fault error. Okay, I am showing you complete program. Let me know what is the issue in my program. Jatin, Roshni, and Rahul, tell me what is the issue in my program. Main program started here, all the initialization. Right, this is my program, main code is here. When I'm trying to resume it, let me restart it. Okay, program is starting here. I should click on resume, my program should run, right? But it is going into the hard fault handler. That means program is not working, it is getting reset or it has some issue. Tell me what is the issue?
89, 89, line number 89.
Sorry,
Okay, there is a while loop. I
there
have
is
seen there is a while loop,
here,
continuous while loop.
here,
Not there. I have seen somewhere else.
there
The
is
while loop is continuously. Yes, yes.
no, this is not custom
Okay,
file, it's ready-made file, it's not
okay,
here and over here.
okay, 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 okay.
I am talking about this program. Jatin, who's
I
Jatin?
guess some issue with the clock.
Sorry, issue with
Clock.
clock.
Yeah.
No, it's very basic. You are missing. Everyone, check your program because I do not have a while loop here. Got it? Should it work now? Yes, it's not going into hard folder, right? Let me show you on camera. It is working now. This is our green button. Okay, sometimes you have to take care of this kind of issues, and this is we call actual debugging and finding the bugs into our code. You can also see ITM data console when you are pressing button. This thing should be print. Or you have done, if you have done, everyone, Rahul, Jatin, Rojni, and Praveen, Sumit. When you press button, this log should be print. सेट किया तुमने डिबगर पे ले कॉन्फ़िगरेशन डिबग कॉन्फ़िगरेशन सेट करी थी. कौन सा है?
सर ब्लिंक
ये चल कैसे रहा था ये?
अच्छा
कोड ही नहीं। ये कौन सा है? हेलो वर्ल्ड टेस्ट, ये वाला प्रोजेक्ट है? कुछ भी नहीं था ना।
नो सर, लेकिन ये वाला मैंने अभी बनाया ना, ये तो पहले वाला है हेलो वर्ल्ड टेस्ट जो आपने पहले किया था।
कोड इसी के अंदर रखा हुआ है। ये तो है, ये तो कुछ के अंदर ये क्या है, बटन रीडिंग वगैरह यही तो है सब कुछ। क्या कर रहे हो ये? इसको पहले ट्राई करो, हो जाएगा। इस पर चलो। हेलो टर्न प्रवीण सुमित।